Okay, we got 3 more weeks left for the EOC, and this is the last unit. It's coordinate geometry and algebra. So today we're going to be graphing order pairs, estimating the slope, estimating the midpoints, and estimating the length or the distance of a line segment. So the first thing we want to do today is we want to graph the order pairs. So you're going to graph the first order pair, which is 4, 8. Remember, order pairs are x, y. And the x-axis is your horizontal axis, and the y-axis is your vertical axis. So we want to match up 4 on the x-axis and 8 on the y-axis to create a point, and that would be our point. Then we want to graph the next order pair, which is 6, -2. Again, remember 6 is your x-coordinate and -2 is your y-coordinate. So you want to match 6 on your x-axis and you want to match -2 on your y-axis to create a point. So that would be the point 6, -2. And then you want to create a segment. So you draw a line connecting both endpoints of your segment. So in order to estimate the slope, we've got to remember from coordinate or algebra that slope is just the rise over your run. So the easiest way to do is count it on your graph, and you want to do that by creating a right triangle. So if you take your pen and you create a right triangle by connecting the two endpoints of your segment, your right triangle should look like this. And to find the slope, you're going to count the rise, which would be from the bottom point to the top point. And if we count those boxes, that would be our rise is 10 and our run is 2. So notice we went -2. So our slope would be rise over run, which equals rise is 10 and my run is -2. So my slope would be equal to -5. Next, we want to estimate our midpoint. So to estimate the midpoint, what we're going to do is, again, we're going to take our rise and our run. And our rise and run is 10 and -2, and midpoint means in the middle. So if we half the rise and we half the run, our midpoint's going to be rise 5, run 1. So our midpoint would be here. So our midpoint would be 5, 3 if we name the x-coordinate and then the y-coordinate. And the last thing we want to be able to do is to determine the length. And we already know how to determine the length because, as you see, we've got a right triangle. Here is our right angle. And that would make the segment the hypotenuse. So we would want to use the Pythagorean theorem to find the length of the hypotenuse. So a squared plus b squared equals c squared is your Pythagorean theorem. And we're going to substitute in 2 for a, so 2 squared, plus substitute in 10 for b, 10 squared. And we want to find the length of the segment, so that would be x equals x squared. So if we work our Pythagorean theorem and we follow the order of operations, 2 squared is 4, plus 10 squared is 100, and we're going to add that together to see what x squared equals, or the length of the segment. So 4 plus 100 is 104. That is the value of x squared. So we want to find out what number do we need to square and get 104, and that's not going to be a whole number, so you can do that by taking the square root of both sides. So if I take the square root of 104, my value tells me that the length of the segment is 10.2. So the length of the segment is 10.2, or you could say the distance from one endpoint to the other endpoint is 10.2. Now I want you to work on this and do your best today, and we'll have another video for tomorrow. Thank you.